In the last couple of videos, we understood what is a transistor, how a transistor works, and different types of configurations, correct? Only one actually you have studied, which is the CE configuration. Now let's try to understand what are the uses of transistors. Mainly three we have to understand, okay? A switch and an amplifier and an oscillator. So these are the three things what we are learning. See, a switch, look at this particular circuit. Okay, now in this circuit, we try to understand how a transistor acts like a switch. See, a switch is what basically to switch on and off. That is the whole point, correct? How can a transistor act like a switch? Like in the sense, with the help of transistor, we switch on the circuit or switch off the circuit. Now here, we are going to use KVL for the base part. So as you can see in the circuit, for the base part of the circuit, we'll use KVL. So what you are going to get, see, we'll get minus VBB plus IBRB plus VBE is equal to 0. Transpose the VBB that side. So you get VBB is equal to IBRB plus VBE. Correct? This is the first equation. Now what you do, apply the same KVL, but take the output side. That is the emitter and collector side. Okay, if you take the collector side of it, now what we'll get? VCE is equal to VCC minus IC into RC. Again using KVL. Now that VBB, that basically is the input. Correct? So VI is equal to IBRB plus VBE. And the output is what? Whatever we are going to get in the collector side. Correct? So we can say VO, the output, is equal to VCC minus ICRC. Now what we'll do, we'll take in such a way that suppose if the input voltage Vi is less than 0.6 volt, then what we are going to get, this region is basically the saturation region. Vi is low, so VO is high. That means practically the output current, that is IC, will be equal to 0. Since IC is 0, we say that the circuit is in off condition. If the circuit is in off condition, that means, so the transistor is acting like an off circuit, or it's an off switch. Suppose if Vi is greater than 1 volt, then the output is low. If the output is low, then IC becomes maximum. The transistor is in on state. Since the transistor is in on, the switch is on. So now what we do, we try to keep the transistor in either in the saturation or the cutoff region. Okay, we don't try to keep it in the active region. Okay, look at this particular graph. From this you will try to understand, or you can understand. The cutoff and the saturation region, this is where the transistor is going to work. So now you understand how transistor acts like a switch. Correct? So in the next one, we'll understand how a transistor can act like an amplifier.